Hello and welcome. In this lesson, we'll look at some applications of rational functions, and I brought in two examples for us to look at and discuss. Whenever we solve word problems in class without a failure, I get the same constant common reaction from my students saying, "Oh, I don't like word problems," or even better, "Word problems don't like me," or "I've never been good at solving word problems." As a matter of fact, solving word problems is very similar to solving equations or inequalities. But there are two ingredients that we need to add to our abilities to solve equations or inequality. Number one is patience. And number two, confidence. So they are tied in together and they help each other grow. I'm going to start with patience. And I'm going to say that whenever I solve a word problem, I do not stress myself out thinking, oh, I have to read this and I need to find a solution, what exactly is given, what I have to find, and I need to understand this because I am not very good at this. So when I read the problem for the first time, I read it just as if I'm reading a story, because when we solve word problems, we have to imagine or picture a situation. And I want to know what the story is about so that I can create an image of what kind of problem I'm solving. And I try to be very patient with myself, thinking I don't have to understand everything the first time I read it. I don't have to learn everything the first time I learn it. I have to make a second attempt, a third attempt if necessary. So here we go. A drug has a beneficial effect if the concentration in the bloodstream exceeds a certain value, which is called the minimum therapeutic level. The concentration C after T hours is given by the equation, so I see some rational function here, measured in milligrams per liter, okay, and if the minimum level is 4 milligrams per liter, we have to find when the level is exceeded. So all I got from reading this word problem is that it's a problem that deals with concentration of the drug in the bloodstream. So I didn't focus much on the numbers given. I know that I am given some values and I have to find some others. But I read the problem the second time with the intention to collect the information and try to identify what I'm given and what I'm trying to find. Whenever you are given an equation in a word problem, you're given a very big piece of information. And I start off by writing that equation because, number one, it helps me familiarize myself with the variables in the equation. And number two, I can see what kind of function I'm dealing with. So at this time, I'm working with two variables from what I see, the variables T and C, and this is a rational function. So now I'll read the problem one more time. A drug has a beneficial effect if the concentration in the bloodstream exceeds a certain value. Okay. It's called the minimum therapeutic level. So think about a drug entering your body. The concentration will go from 0 to hit a certain value when the drug will actually start working for your body, and then it will decrease over time, and that's the time when we need to take another pill. So the concentration is given by this formula. So now I focus on the variable. So CT represents the concentration. And if it helps, write a note in here for yourself. So we're practically writing the word problem, but now with our own words, our own understanding. So we are translating this chunk of words into a more structured information. And it is measured in milligrams per liter, and I'll write this down to remind myself that I shouldn't forget the unit measurements when I'm solving a word problem. Now, this is a very important part of the word problem. It's the question asked and the information given. So I'll focus harder on this, and if the minimum level is 4 milligrams per liter, so when we say minimum level, it doesn't mean the lowest level, Okay, so we understand somehow how drugs work, and the concentration is given to be 4 milligrams per liter, the level where they start working. And we have to find out when is this level exceeded. So we're going to say that we have a new word in here, exceeded. Exceeded means greater than. So we want to know when the minimum level of 4 milligrams per liter is exceeded, or when the level is greater than 4. So what we are finding in here then is when is the minimum level exceeded. So minimum level must be greater than 4. Remember that the concentration is given by the equation 20t over t squared plus 4. So we have to think of replacing or rewording our unknowns. So our unknown is concentration bigger than 4. So concentration is 20t over t squared plus 4. And we want this to be greater than 4. And we need to know the time when this becomes greater than 4. So when you look at this new statement now and try to kind of separate it from the word problem, because that would be your next step in the process of solving the equation, we think, oh, this is a rational inequality, and I only have one variable, the variable t. I have to solve the rational inequality then. Now, one thing that we need to remember about our variable here, the variable represents time, and time has its limits, and usually in word problems, we make sure that we state the value of time before we start solving the inequality. It has to be greater than or equal to 0. So in order to solve an inequality, we take all the terms to one side of the equation. And that's what we're going to do. Next, we want to bring all the terms together, which means that minus 4, which has a denominator of 1, must be given a denominator of t squared plus 4. So now we have the fraction, the inequality in a single rational expression in one side. So 20t minus 4t squared minus 16. And the denominator is t squared plus 4, bigger than 0. And I will try to rearrange the terms from highest to lowest degree, plus 20t minus 16 over t squared plus 4, bigger than 0. So we will have to study the sign of this rational expression and find the time when the rational expression becomes positive. So for this, we will have to study the signs of both numerator and denominator. You probably have noticed, or maybe not, that the denominator is a quadratic. And when you think of the graph of this quadratic expression, that would be a parabola that is 4 units up, which means that t squared plus 4 will always be a positive number for any value of t. Now, if we took into consideration that the value of t has to be positive, this would be the exact shape of this graph. So it's going to be a positive number, which tells us that the sign of this inequality, rational inequality, will be determined based on the value of the numerator only. So we're going to find the zeros of the numerator, because we know that the zeros of an expression will separate the positives from the negatives, right? So negative 4t squared plus 20t minus 16. So we're going to take out negative 4, and we have t squared minus 5t plus 4, or negative 4, t minus 4, t minus 1. So the zeros will be at 4, and 1. And now we're going to build up the chart. And on the chart, we're going to list all the possible factors in the rational inequality. So to make things a little bit clearer here, what I'm going to do is rewrite the rational inequality in factored form. So we have the -4, we have t minus 4 and t minus 1, and denominator t squared plus 4, which we said won't change sign, but we'll include it for now in the chart. So there is one very important thing in this case that we need to discuss. You see that here we have a factor that is negative. So two things that can be done. We can list the -4 as one of the factors, or we can divide both sides of the inequality by a -4. Now, if we divided both sides of the inequality by a -4, that will reduce the coefficient. So we'll have just t minus 4, t minus 1 over t squared plus 4. And then the sign of the direction of the inequality, because we're dividing by a negative number, will switch to opposites or less than 0. So we can solve this new inequality. Now remember that when solving rational inequalities, we can divide by the same number, both sides, but we cannot divide by the same expression because otherwise we lose solutions. So here we go again. This is the number line that represents time from 0 to infinity. Basically, we don't really go to infinity with one little pill. So I'm going to list the factors, t minus 4, t minus 1, and t squared plus 4. And here goes the sign of the left side, t minus 4, t minus 1, t squared plus 4. So we're studying the signs of each of them. So here we go. We have 1 and we have 4. So we have the 0 at 4 and the 0 at 1. And t squared plus 4 doesn't have any zeros for the reason that it's going to be a parabola that is above the x-axis, and you can tell from solving the equation t has to be the root of a negative number. So here we have negative and then positive. Here we have all negatives after the 0 positive, negative after the 0 positive. T squared plus 4 is always positive. You may choose not to include it in the chart. And now we'll marry the signs together. So we have 2 minuses and a plus, a minus and 2 pluses, and then 3 pluses. Remember that in our inequality, we wanted this to be negative, which tells us that we are looking for this particular solution, which will happen for the values of time between 1 and 4 seconds. So therefore, we're going to say that the concentration of the drug in the bloodstream will be above 4 milligrams per liter within the time interval between 1 and 4 seconds. So this is the first example, and we're going to take a look at the next example in the next video. Thank you for watching, and don't forget to check the solution to the next word problem.